everyone. Let's try to solve this question, and the question is 3 raised to the power x minus 3 raised to the power y is equal to 234. We find the value of x and y, and x and y belong to an integer. So let's start. The given information is 3 raised to the power x minus 3 raised to the power y is equal to 234. Now look at this first term. This is a 3 raised to the power x. So we add and subtract y in power. So subtract and add y. And this is a 3 raised to the power y is equal to 234. Now in the first term we use this exponent rule, which is a raised to the power n plus m. This is equal to a raised to the power n multiply a raised to the power m. We apply this rule on the first term. So this will become a 3 raised to the power x minus y multiply 3 raised to the power y minus 3 raised to the power y is equal to 234. And in the next step, look at this 3 raised to the power y involved in this term. This is a one term, and this is a second term. 3 raised to the power involved in this term. So we factor out 3 raised to the power y. The remaining value will become a 3 raised to the power x minus y, and this will become a just 1. It's equal to 234. Now look at the left hand side. Left hand side is a product of two values. First value is 3 raised to the power y, and the second value is 3 raised to the power x minus y minus 1. So that is why we split this value 234 into two values. So the factor of 234 are 2 multiply 117. Second factor is 3 multiplies 78. This is also equal to 234. And the third factor is 6 multiplied 39. And the fourth factor is 9 multiplied 26. And the last fifth factor is 18 multiplied 13. Now look at the case 1. If we take this factor, so this implies 3 raised to the power y, this is equal to 2, and 3 raised to the power x minus y minus 1, this is equal to 117. Look at this, y is an integer and 3 is also integer. So 3 raised to the power any integer is not equal to 2, so we cannot use this case. So this is not valid case. Now look at the second factor. This implies 3 raised to the power y is equal to 3, and the second equation is 3 raised to the power x minus y minus 1, this is equal to 78. Now look at this, we write this 3 as a raised to the power 1. The base are same, so we can compare their exponent. This implies y is equal to 1. Now look at this, if we add a 1 on both sides of this equation, then 3 raised to the power x minus y is equal to 78 plus 1, and this is equal to 79. So we cannot write this 79 as a power of 3. So we cannot consider this case. The case 3 is 3 raised to the power y, it's equal to 6. 3 raised to the power x minus y minus 1, this is equal to 39. Now look at this, y is an integer, 3 is also integer. So 3 raised to the power any integer is not equal to 6. So we cannot use this case. Now we select case number 4, which is a 3 raised to the power y, it's equal to 9, and 3 raised to the power x minus y minus 1, this is equal to 26. Now look at this first equation. We can write this 9 as a 3 raised to the power 2, which is also equal to 9. So base are same, so we can compare their exponent. So this implies y is equal to 2 in this case. Now look at the second equation. This implies 3 raised to the power x minus y. If we shift this 1 to right hand side, then this will become a 26 plus 1, which is equal to 27. This is equal to 3 raised to the power x minus y. So we write this 27 as a 3 raised to the power 3. It's equal to 3 raised to the power x minus y. The base are same, so we can compare their exponent. This implies x minus y, this is equal to 3, and y in this case it's equal to 2. So this implies x minus 2 is equal to 3. Shift this minus 2 to right hand side, then x is equal to 3 plus 2, which is equal to 5. So in this case x is equal to 5. Now in the last, we consider this last case, case 5. In this case 3 raised to the power y is equal to 18, and 3 raised to the power x minus y minus 1, this is equal to 13. So we cannot write this 18 with base 3. So this implies this is a not valid case. So in our question, the value of y is 2 and the value of x is 5. So we have done.